Zoom has some funny nuances, still learning about.
Mm. New ones pop up all the time too.
Okay, we'll get started now, 3 p.m. somewhere. Welcome to the Propeller 2 live forum. I'm Ken Gracie. Today we have Peter Jakacki presenting the P2D2 module from Australia. Welcome, Peter.
Hi, guys.
And
Hi, Ken.
before we release you to the wild, a few small things to go over. I just love all the sales opportunities of the captive audience. I can't help myself. You're probably used to that by now, but just so you know, all the Propeller 2 boards have shipped. We're caught up with back orders. That's done. Thanks for your patience. For those who wanted Rev C, I think we have like 60 or 70 more coming into inventory. So all done, and these displays have shipped as well. I was able to get 150 more of them. If you didn't get one, you're not left out. More are coming, and we're going to keep the price as low as we can at 40 bucks. And when these are gone, I'm switching to a 9-inch display that is also really nice, and we'll have the cable and the adapter board on the back. So coming, new products. Okay, so as I've mentioned in the past, we're partnering up with Micro in Serbia who makes the clickboards, who is just shoveling tons of these through Jakacki and Mauser. They have thousands of them, and their goal is to put out 2 or 3 a day. So we've designed this adapter Michael has for us. Thanks, Michael. And we think this is, in the near term, the fastest way to get support for their modules on the P2 eval board. So our intent, provided everyone's interested, is that we start to stock the modules for which we have objects. So this adapter will get in stock. It should be dirt cheap, just cost of the parts, because you're going to probably need a lot of them, and allow you to use the modules. For example, Johnny Mack came to us and said, hey, here's my RS-45 design. Can you make this, please? And I said, yes, but after really looking at this more, this is the kind of thing that we should really be getting from Micro E, because we will be a distributor of theirs. So I'll stock their boards, and hopefully we'll get objects written for them. As the objects are produced, I'll get the boards in stock. So I'd love to know how y'all feel about that too. Maybe you can tell me in the chat. But I mean, the thing is, it costs us thousands of dollars to start up a board, and there's no real financial benefit. It just takes our time. We got to focus on objects, and these guys are doing it. So I'm trying to save everybody money and time to market just by using what they have. So if you like that, Roy Eltham, thanks. I got to hear from others though if it's going to work for you. Like I said, they have thousands, all the latest designs. Go look at it on Micro E, and I'll stock them too. So other products coming. There's an adapter for the WX module for wireless programming, and we're actually going to see this in September at a P2 live forum. This is really working well. It's super fast. Just takes a little adapter. The accessory sets are still out of stock, waiting on circuit boards. All the parts are ready for the pick and place. We're just running our pick and place rampant right now after being delayed with COVID, pandemics, and shorter schedules. We've kind of run low on a lot of inventory, but we're really pressing now to run the machine like crazy and then build up a bunch of products on the other side where we just need to do testing. So having everybody do what they do best should get this problem solved pretty quick, because we're out of stock of a number of items. So I'm thinking 3rd week of August on those. Last week, I mentioned to you the ESP32, and I'm just learning about this device, so it's new to me. And we have several customers who are wanting to use it with the Propeller 2, and I see this as a key partner of the P2, because more than half of the products that get made will be IoT connected for embedded products. So I want an absolutely superbly easy to use object for the ESP32. And we're talking to a few people, you already know them. Matteo and Riley, who've been P1, P2 programmers for many years. They've appeared on our forums recently about writing this object for us. And before we got too far, I will take this scope that we're looking at, scope of work, and post it on the P2 forums. Likely do that tomorrow. And I want to get some input on the scope, because this driver that they write should be trouble-free, professionally written, you know, like something Johnny Mac would do, but with a lot of capability for really serial pass-through control to and from the P2, and whatever else people want to use it for. But you know, I'm kind of surprised this hasn't been done already. I think the other web features are mostly used with the ESP32, but we're really looking at serial pass-through capability here for web connectivity, because all the products I've seen so far with P2 have web integration already. So this will be on the forums, and want you guys to comment on it freely and tell us what you think, because we will be paying for the development of it. No new objects this week. Summertime. So Johnny Mac is quiet. Got to rustle him, bring him back with some more code production. So still trying to get Chip rounded up to this. He promises me very soon. They're both dealing with my impatience. Also, if you make a product with P1 or P2, I've mentioned we're building a new website, and the new website will reflect very favorably on our commercial interests with the P2, because we've appeared so education only in recent years. But as you all know, because you're all here and you've been part of our group for many years, commercial products are very important to us. And we hope to show all kinds of stuff, whatever you're doing. This is one I grabbed this week. A customer sent to me we're working with, Near Space Launch. You can check them out. They are, as far as I know, probably the widest outreach for education. They have a Propeller 1 what's the name? CubeSat form factor board that is actually programmed in Blockly Prop, and then it has a couple of accessory boards on it, and they're putting these out to schools. In our country, in the USA, the airspace is easy to access with these balloons, which is very unlike other places where STEM education is important. So you could do this provided you follow the rules. And these balloons go up to 100,000 feet, and they have phases of their program that'll actually allow you to put your project on a satellite. So you'll be seeing more of them with us in the near future. All Propeller 1 stuff. And then tomorrow, won't talk too much about this. Anybody know what this might be? Garbage to some. Nope. Anyway, 57 bucks. It can be yours. And today we have P2D2 from Peter, and this is the best marketing name an engineer has ever chosen for a product. So really good job on that, Peter. And we're anxious to hear all about it, and people are got loads of questions for you. So on to you, and thank you for sharing today.
Thanks, Ken. And this is all a lot of last minute stuff. So if you can help me out and help me stick to some kind of agenda, that would be really good, timing wise. So I'm in the workshop at the moment. You can see the mess up behind me and everything. That's fine. But I've just set up so I've got the webcam camera here, shares off the computer, and another IP cam will come up onto the screen as well. So I'll do it all through the browser. So I only have to share the browser with you guys. Now, as you guys know, P2D2 was originally conceived as well, in fact, it wasn't originally conceived. I was originally doing a data sheet for the P2. I needed pinouts, and I needed, references, packages, etc. And as I was doing this, I thought, well, I have to do a reference schematic. And so what happened was that as I'm doing the schematic, I think I've got to expand on this, and now I've got to do a board. And before I knew it, I had to design a board. And so the first board I designed was this one. Now, let's see if you can see that okay. All right. So I'll get this right in a moment. There we go. That focusing? Probably not. I can switch to another view soon. but that's the trouble with having all the clutter in the background. I might just swap it around a little bit here. Sorry about this.
It's all right. Hold it still, and I think we'll get it a
Yeah,
better
yeah,
focus.
Yeah, it tends to focus up on everything else, and that's the trouble. So, and it won't do a macro, but this is original glob top chip and linear regulators up on here that you can see up here, just there, linear regulators, and a little switcher right in the middle there. So that was the original P2D2, and that one was actually made up. That was made up by you guys, was it, Ken? Because I sent the boards and I didn't have any chips, and yeah, so you guys.
Yeah, that's right. You sent us boards, and the day the chips came in, we mounted them.
Yeah, so that's it.
And
so
then sent you
I can't
chips.
remember. Yeah, that's it. Yeah, so I can't remember whether it was. Yeah, it was a chip was assembled on there, all the parts. I can't remember, but anyway, and that worked amazing. So that was pretty good. But the first P2 chip that we had, of course, drew a lot of power, and we were worried about power requirements. So what we had to do, of course, was actually look at the regulation for it, the switch mode regulation for the I/O, as well as for the 1.8 volt CPU power. So so what happened was, then I did a revision of that with a dual switch mode regulator. I'm going to switch to another view here. So you can see this a bit better. I'll switch to an IP cam view here.
And I think, Peter, too, the very first P2 programming was done on that board. Yeah.
Yeah. Well, not true, because FPGA.
Okay.
That's okay. Cool. This is silicon. That's true. And the very first programming that was done was through tar codes built into the ROM. So when Chip fired up, he was able to talk to tar codes and make sure that it was alive, everything was talking, etc. So what I'll just do is I'll just share this screen with you guys. It'll be better than just looking at me. And where are we now? Okay, here we go. So I share the browser window. There's a tiny bit of a delay I've noticed, but I'll just make sure it comes up fine. Right, okay, so there we go. So I've got a little shot here of the, this is the original here. See if we can get that. Once again, it won't focus up. Typical video mode, but there's the glob top one there. I'll just put it back up here. Accounting for the delays up on here. So over here we have the original version. I'll get a pen, I'll point this out. Okay, so over here we have the original version, and that had the linear regulators. Straight away we had to make changes to it with dual switching regulation and a few other things, as you notice, USB serial. At this point, when I originally did the design, by the way, the original one just allowed for a prop plug type connection. So that's all we had. And then I had a transistor reset circuit on there. Now, how's this going for lag? I'm not, it should be fine, yes. It'll be right on your end. So this one allowed for the transistor connection here, prop plug. And then I went to a USB design. What chip would I use? I could use a CP2102 because they're very small, like that chip that you see down here, perhaps. I don't know if I can zoom up any further to that, but when we look at that particular one there, and we'll try to bring it up here a bit better. Does it come across? Not very well. This is where we need all these GoPros. So tiny USB chip went on there and decided to use a micro instead of a CP2102, Scilab's micro that's footprint compatible. Just needed to get the code running. Easier said than done. But there were lots of bugs, lots of things to sort through. So, but at the end of the day, that micro has made a lot of difference to the actual P2D2 board, and it really makes it a a complete programming system as well. Looks
So
after a
just
lot
to
of.
confirm, that's the USB bridge chip, right?
Yes. So the USB bridge chip. Yeah.
2102.
Yes. So well, the CP2102 is just a dedicated USB serial bridge, and what happens is that that's fine, but I wanted some extra functions to handle the reset, nice reset coming out of it, and a few other little things, and rather than having separate circuits. So we put the smarts into the chip. So we had JMG. JMG looked after this in New Zealand. Thanks, JMG. And so we collaborated there and sorted out, tested it all out, sorted out a lot of the bugs and added features to it. And now that little tiny chip looks after not only the reset, but also looks after the SD card power on and off, looks after, I forget all the functions on it. It's got A to D functions, everything on it. And it also looks after the clock generator, which is the original board didn't have. And I think what we're going to see is, I'll put this in the center here, so the original board didn't have a clock generator. And so we added this one to it. I'll bring this other one up. I'll find one here that looks a bit better. Declutter this, and we'll get this one up here. Here we go. Okay. So over here, we've got the USB chip. And then over here is a clock generator chip. The trouble with these ones here is that the default, you need a clock to get things running on the P2. And the trouble is that you can order them pre-programmed, but you know it takes a long time, etc. But you can load them up by I2C. So this is what the USB bridge chip does. It also loads that up while the P2 is being reset. So it loads up the clock generator, and even though we have a 25 meg crystal on there, well, the crystal's up here in fact, 25 meg crystal. What happens is that it then generates the 20 megahertz, standard 20 megahertz that we have for the P2 eval, so that we don't have to make any changes to the software to suit. I also have 26 megahertz GPS crystals, and they're 0.5 ppm and dirt cheap. So I can also put that in as well. I have configuration tables built in there, so I can just say, this is my option, I want to use 26 megahertz instead, and it will generate the nice 20 megahertz out of there. Also have a couple of extra outputs from that clock generator. By the way, while we're talking about the clock generator, that come through on little pads underneath. So they are available for special uses. We were looking at HyperRAM originally, using a separate clock, phasing it. So at the moment, they don't have any uses, but the clock generated chip is, and the crystal combination is very versatile. So hopefully everything's synchronizing up here, because I have all these screens all out of sync here. But any questions so far, just before I go on?
Carol Moore asked a question, I think it was general, not so much for P2 maybe. Is it possible for me to detect when USB is connected or disconnected with the signal without resetting the P2?
Yes, because the firmware is such that without USB connected, I've tested this up in external power configurations. I can still talk to the chip, and I know the total status, the reset status, what reset the board, was power up and so on, USB serial event, or no USB serial, and so on. So we can tell from that, but nonetheless, the USB serial chip is not powered from the USB bus. This is the important thing with a lot of Propeller designs. You have this problem where the transmit from the serial chip comes into the prop chip, and well, that's not a problem there. It's the other way around, into the receive of the serial chip. Powers that up, phantom power, and you have all these problems because you have a fairly primitive reset circuit. You don't have any of those problems with this. This is powered by the 3.3 volts from internal regulation, and it also has a steering diode from the USB, so we can just power that straight from USB. So we probably see that in the photo here. There's my hacked prototype over here, the current R4, which is has the firmware on board to suit the new PCB, which I'm going to talk about shortly. So one of the things too with that serial, by the way, is that not only can we detect that the USB is not connected, but it's also sensitive to the actual data coming through. So we can detect sequences, special sequences, etc. And it also detects the serial loader. So it says, this is a serial loader. I am going to generate a reset pulse for the P2. A simple connect, disconnect event will not trigger a reset. So same with the terminals and so on. This is an important thing. I didn't want anything to interrupt the P2 if it wasn't valid. Sorry, I just have a little drink here. I'm trying to keep track of where I am with this. So I hope I'm not wandering off. So did that answer your question, Ken?
I think it did, yeah, and Jeff is furthering it in the chat.
Yeah, good. So so that's the serial part of it there. And so important part of the, I might go to a schematic here. I'll switch over. I have schematic for the P2D2.
And just a comment, I don't want to take up your time with this one, but big switch here from FTDI towards this device in Propeller land. And it seems like others have already made it. We have not yet, but are watching. Okay,
yeah. This is true. FTDI, everybody knows this. They work. When you look at the price, when you look at the price of the chip, and you compare it to a micro that has all this flash and all these capabilities, USB micro, you think, well, why should I buy an FT232 chip? Well, because you plug it in, it works. Well, the thing is that this one doesn't work when you first plug it in, but you can load firmware by the USB. So it does have a little bootloader in there, HID bootloader, and that's what we do. We load it up in the factory. It'll be pre-programmed. But if we ever have a firmware update, extra features, simply plug it into the PC, put a jumper across 2 pins, and load in the new firmware. So you have all this extra functionality. This is to go through all that functionality. There's a lot there, and that might be another day. Today we're really just talking about the hardware features, and we have a schematic up on here for the P2D2 revision 5. The only real difference between the current one that you see here that's been hacked and the new board that's coming back with a whole batch of other boards is the fact that it makes sure that the P2 is in reset even when there isn't enough power or voltage to enable reset properly. So we have a default pull down resistor just over here. I think you can see that there. Do that one again. So I might just increase my mouse size here so you can see where I am.
And for anybody who wants to zoom this, if you go up to the top of your window, view options, zoom ratio, you can zoom in, then move it around, or I think there's a keyboard shortcut.
And what I'll do is I'll also zoom up here. Okay, so we're talking about zoom. So there we go. And get this working right. Web browser is handy, but it's not exactly a PDF viewer. Okay, so here we go. So that's zoomed up there now. And what we have is this bridge chip. Here's a USB over here on the left-hand side. That's zoomed up there now. Yes. And it acts just like a USB serial bridge, except if it's not connected to USB, it will tri-state or float its transmit line. So it won't try to drive it. However, even if it was driving through the TX over here, there's a 220 ohm resistor there. So there's no problems. We can come in with an external serial and override that one there. Now, I just noticed one from, yes, see the chat messages come up, but James is mentioning about that UB3. So if you have any questions about that, you can ask him. I've got, I converted I disassembled the compiled library and everything else from there back into assembly source, reconstructed the source, and now I can just reassemble it in a fraction of a second, make all those little changes to it, add all those extra commands to it, and so on. So there's two versions. There's the original version, and there's the My Assembly version of it as well. So on this particular chip here, this is a good thing about this. As us Aussies will say, it's the beauty of it. It has that tri-state on the transmit line. It can operate without USB being plugged in, and it will power the board from USB as well. It has a steering diode just up the top up there. You can see through V-bus USB powered up the top of the screen. I won't zoom that up any further at the moment, if you can see that okay. And of course, a USB protection switch in here. Not totally necessary, but these are very small and very cheap, so in they go. And right over there, the power goes through. You can see that dropping down through into the dual switching regulator. Now, these are a little bit more expensive than the tiny little switching regulators and inductors that are available, but it's a lot smaller. And I didn't have a lot of room on the board. So in it goes, and it does the job very well. 2 amps on each output, and it's been programmed to deliver 1.8 volts to the CPU, but it can also be boosted a bit too. So I can change those resistor values in there. On the other side, on the 3.3 volt side, I don't actually have 3.3 volts. We have the output of the switching regulator has ripple on there. And as we know, we have sensitive A to D and all kinds of issues there. So it outputs 3.6 volts. And that 3.6 volts goes across to the linear regulator just over the right of the screen over here, which outputs two dual outputs, one to the A port, one to the B port. And so we have 3.3 volts, and it's all nice and clean and filtered there as well. So when we power something externally, we can add a regulator, a little LDO, and power it from the 3.6 volts. I'm going to show you later too, by the way, when just talking about that power. I have a P2 PAL PCB that goes on the back of this, and it's powered directly from 3.6 volts. I'm not even regulating down because there's no problems with 3.6 volts on 3.3 volt components. And in fact, the inputs tolerate plus and minus 300 millivolts as well anyway. So I have that on there. And so you can see that's being powered from the USB or from external power that's coming in. And those pins are available on the headers, those 5 volt in, or even the 3.6 volts. You could power that from a lithium battery, and that will still work fine too. Back to the, any questions about the power supply and that arrangement there?
Everybody's free to unmute their microphone if they want to ask it instead of type it.
It'll be faster.
Yeah, I think you can continue on, Peter.
Yeah, okay, that's good. So, so when you think about the power requirements, we know that on the P2 eval we have 3 amp regulators, but remember, P2 eval is for testing the P2 chip. It's evaluating and pushing to the extremes, and it has all that on there. With the P1, we never ever pushed that to the extremes with all the times that we've used it. Same with P2, I pushed that pretty hard, but it's if I were to use 2 amps on the 1.8 volt line, that's 3.6 watts already. And then on the 3.3 volt line, there's another 6.6. So you can see that this the actual power dissipation will be very high. You wouldn't want to run it at that power level, but it's there. The margins are there if we need that for external uses or anything else. And the other thing too is that we rejected P2 hot because it could draw draw 5 watts at maximum power. So we certainly wouldn't want to go anywhere near there. So the regulator is more than ample for all the applications that P2 needs to be used in. Getting back to that USB chip, because we looked at the power that went to the USB chip. So this one will work fine. I'll just point to the screen here. So this one will work fine with external 5 volts, 3.7 volts, or the USB power.
Peter, tell us the part you're pointing at. I'm not seeing the mouse cursor.
Okay, so I was trying to get the mouse pointer up, but because of the browser, it's not working too well there. So I will, right in the middle of the screen here, I'll try to recenter this.
Yeah, I think that just works when you tell us where you are, what the text label is.
Yeah, so I might just do that because the pointer is not coming through very well up on here, I can see. And but if I keep it in the browser, I won't have to change the share around. So right in the middle of the screen, we have that EFM 8UB30F40G. And so that's a little 50 megahertz internal clock, 8051, zips around, has 40K of flash and a few K of RAM, and more than sufficient to handle all the USB work. It has a USB interface on there as well. So that works very well as the reset chip, as it was originally intended, and as the serial bridge, but also I2C bus. We can communicate to this from the P2 as well. So after the P2 has been reset, it now turns the USB chip now turns into a I2C bus slave. So we can talk to it from there. I'm getting my USB and I2C mixed up here, so bear with me. So we have I2C coming in, and we can talk to it, and we can read analog inputs. We can read the 1.8 volt line. We can read the chip temperature. We can read many other analog readings that gives us an idea of what the input voltage is. So we can calculate it from there as well. And also too, it can read the flash. We can reprogram the flash. And also change the configuration tables. We want to use a 26 meg crystal, or we want to change the way the clock generator starts up, and we want a clock coming in without using the P2 PLL, tuning the P2 PLL. We can have the clock generator generate the precise clock that we need. So that's a very handy feature there too. There's a lot of other features, but that's the main one. And the other thing too is that when we start up the serial loader, what do we want to do? We don't want to boot off the flash. We don't want to boot off the SD. No need to jump for that, because if we look to the right of that chip there, we see P0.2 going off to P99 through a little resistor there. What that will do is that will force the P2 at boot to only load from serial. No problem. So we leave the flash activated, we leave the SD card, SD card in there, and we can just load it up serially. And that will only happen when we're using the serial loader, because it's looking for a reset pulse that comes out from the DTR line internally. So we don't expose the DTR line externally, but we process that internally. So that's one of the main features of the P2D2. Any questions so far with that part of it there? Just unmute if you like. All right, so going on to this next part down here, one of the other things this USB chip does is in the center of the screen, we have a SD power switch there. Another one of those little tiny switches, protection switches. And also, I just noticed a question there about the maximum speed for the USB UART. Tested this up to 8 megabit. And when I say tested, I mean, this is talking to Tarcos. And this is where we've had the problem with Tarcos. We can spit things at it and it's spitting things back, but not necessarily one for one. And so it's exposed the bugs in the USB serial library. That's been fixed, and we're able to talk to this at 8 megabits. So that's pretty good. I can just go with zero delay, dump in the source code, and it handles it no problem at all. So,
hey, Peter.
Yes.
8 meg is pretty good. So you're not having any trouble on the PC side with the Windows app?
Well, mainly I don't use Windows. I have tested this on Windows with Terraterm, and you can put in the high baud rates. I haven't had any problems with that at all either on the PC side. So I'm running from Linux, and I switched to 8 meg, and the throughput is very high. And we can, like, well, I've done plenty of tests all up there. Of course, over 8 meg, you can't really do it because it can transmit, but can't really, well, receive properly, etc. You know, and so on, because it's where it's sampling, it'll have too many errors. So 8 meg works fine. So James G just mentioned that, yeah, something on the chat there, but it's about the maximum speed. It works really well for me in Tarkos. Unfortunately, a lot of programs don't handle that speed. And there's a lot of PC programs that have trouble going over 115.2K. But there's no problem with running this at those high baud rates. So, I can see that being used a lot too in this design, loading in new firmware or even large files as such. So just getting back to that schematic there, and we might just try to, we had to navigate on this one here. I don't think I can. So what I'm going to have to do, oh, there we go. That's a little bit there. Okay, right in the middle there of the screen. We'll navigate through it all yet. Okay, I think my PC dropped out. Is that right? No, it's still there. Okay. I'm just waiting for that to reconnect. So I have to wait for the, it's not coming up at the moment. Okay. All right. Just check to see what's going on. Everything hinges on this PC working correctly. So I'll just find out what's going on here. This is where it's good to have an assistant looking after all this. That'd be good.
I just can't press the right buttons for you.
No, that's it. And so I might think about doing that next time. I'll do anything like this. I'll have somebody just looking after the system to make sure it runs beautifully. Now I've just got to check what am I talking to at the moment. I'm just talking to the access point and make sure that we're hooked up correctly. And what's going wrong with it. I can change the...
Maybe we can load up some of the chat with some questions that will be happening, yes, or that are on people's minds while Peter gets his computer working again. Like, I'm kind of curious about the form factor parts and where the pins are and power and ground and that kind of stuff. You don't have to answer it now, Peter, but what other questions people have, the overall size of it. I know the availability is a question, and what the projected date will be, those kinds of things, and how the Americans are going to get them and the Europeans.
Well,
logistical type questions.
I might, yeah. I wanted to show a bit more off here, but perhaps I'll leave that at the moment and just answer a lot of those questions. I do ramble on. Now Brian says, Ozprop says he has Windows running 12 megabits using, he has a high-speed FT device there, and but this is a $1 part that we're using on here, mind you, and it's nice and small, isn't it? So 8 megabits, that's pretty good. Now, talking about the layout, the pinouts of this, remember that the latest versions were done so that they're compatible with a Raspberry Pi. So if we take a Raspberry Pi, I'm hoping I've got all this set up here properly. I'm not monitoring anything yet.
That works well.
Yep. So we have Raspberry Pi, and so this is designed with the extra little header on there to to mount up onto the Raspberry Pi. So we can have it sitting up on there, and all the pins are mapped on that extra header there. So if you don't need, I'll hold that up again. So if you don't need that extra header, you can chop that off or leave that on. It doesn't really matter. So there's 2 rows in there of pins, two sets of connectors, I should say. And there's the normal connector that we have on the original board over here. Over here.
That's a 0.1 header, standard spacing.
Yeah, standard spacing, and so dual row, so 40 pins on each, and that gives us, it's a complete breakout of the P2, except for reset and a few other things like that. So all the I/O come out onto those headers.
So you could just put a single row in there and also breadboard this, is that right?
Well, you can put a single row in there. Now, you say you're talking about breadboards there. I might just show you, this is what I consider a breadboard. I might just pull this one out of here. Now, this here, this matrix board, is just plated through holes. And what we do on the other side is use wire, just strip and solder it up. Totally reliable, very compact. You make it exactly the way you want. And on the other side, we can put whatever we want on there. Much better than plug-in breadboard.
Very good.
Plug-in breadboards, really good for op amps and TTL, and maybe even a 40-pin prop. But we've seen a lot of the problems that people have simply because they're using a breadboard, having crystals and decoupling problems and so on.
Yeah, it really feels like moving
better.
on to the P2 breadboards have less and less of a role, don't they?
Yeah, and also too when I do I need some prototyping area, then I normally just have a little plug-in module with some of that the matrix board, make it up out of the matrix board, put a couple of headers on it, plug it in, make it up. It doesn't work, I can replace it and get a much better one, put that in place of it. So that works a lot better there. Just check my connection here too, by the way.
I'm curious too about the Raspberry Pi interface. If you have a project or product in mind where you'll use the Pi plus the P2, or are you thinking about the users?
So I don't have a Raspberry Pi application in mind. That was requested, and it was easy enough to do to add that to it, rather than, as we use the expression here, bodgy up, to change the header, the standard header that we use, just to suit a Raspberry Pi. It defeated the function of it being a P2 breakout as well. So I added that extra header for that, and I don't have a lot of uses for it, but I know that I can plug it into a Pi if I need to directly, and have it sit on there as part of the unit as well. Nice and small. Now we're talking about plugging things in. If I get this system back up and running again, and I'll check that it's all working. Let's see if we can get onto the forum, and if I can get onto the forum here, I have different internet connection for the computer. It looks like it's working again now. So let's see if we can join back up again. I think it is on again, isn't it? Yes, it is on again. So I might just share this screen with you guys. I'll show you the P2 power board, because what we want to just quickly jump to is the P2 power, which is a little layer that goes onto the back of the P2D2, and it just goes on there just like a surface mount type component. Talking about surface mount components. All right. So here's a little ESP32 module, just one I pick up from Mouse or Jakacki. That's a little surface mount PCB designed to be surface mounted to a PCB. In this case, I have another little PCB, thin PCB that solders to, along with other components, and that becomes part of the P2D2. So it becomes part of it there, and so we can think of it as another layer on the board. It'll be a 4-layer board then, 2 here and 2 there. And I can do whatever I want with those extra 2 layers. So that'll be a very nice thing. I might just share that screenshot of that P2 power board up here. If I get that up and going, we'll come back to that in a sec. Waiting, oh, there it goes. Okay, very good. So share that now. I'll just show you the 3D rendering. Oh, I don't need the meeting. Pressing all the wrong keys here. I need an assistant.
Well, what you need is Bob in Canada. He can press the keys for you. Oh, now it's coming up.
Yeah, okay. So here we go. We have the P2 power board. Now, you may have seen this on the forum, the renderings of this, but that is a little layer. I'll just show you how this goes. If you look on my camera view, here's an original P2 D2 board, and has 50mm headers inside of the 0.1 inch headers, and you can put pin headers in there, single row, but really it's designed for being cut all along, halfway along the holes, and turned into a surface map module, much like the ESP32 module. So imagine this is a P2 power board that you're looking at up here, and this could be the P2D2 just as easily, but in this case here, we simply surface mount it to the back of the P2D2. Now, if you can see that well enough, then when you look at the screen share, you will see this surface mount module. It still has the pads intact, but they would be guillotined or cut off when the PCB is fabricated. So we have half holes or castellations, and they're just like that ESP32 module, where you have very fine pitch castellated holes. That surface mounts to it. Looking at the screen share, you'll notice on the right-hand side, that's where the ESP32 goes. So there it is, surface mount holders to that, and the P2 PAL surface mount holders to the back of the P2D2. Straight away, we have, it can hook in through serial port, so we can program over Wi-Fi and talk to it, and it also has the extra reset functions in there necessary to control the P2. And also Bluetooth, because I was talking to Ken before and just realized that we've got Bluetooth and Bluetooth BLE on board the ESP32. And what we can do with that is use the Bluetooth keyboards and mice with that. How about that? So we won't even really need to plug anything in. We can do it wirelessly. That will be really nice. So the ESP32 is on that board there, but it also has a full-size micro SD socket on the left-hand side, so a proper push-push eject socket there. So it'll be very easy, because at the moment the actual P2D2 itself, if you remember, has the, you can see that on my camera here, has the little SD socket inside. That's great for embedded use. It's real pain during development, I can tell you. And that's why I have a little bit of tape on my little SD card, if you can see that on my camera. So this way we'll be able to eject it nicely and change it and test it. Really good for development. Board also has, in the top left-hand side, has the HyperRAM. And so I haven't actually used the HyperRAM yet. I have some chips, and so when I mount that, I'll be able to test out some of the code that's available there for the HyperRAM. But to complement the HyperRAM, and if you want it a bit simpler, I also have the pseudo-static RAM. It's a bit slower, but it's very easy to use, and we can almost treat it like a virtual memory device as well. They're very easy to use. Some indicator LEDs around the center of the screen there, general purpose ones that we have. This is all on the port B side at present. So we have some I/O there. We have a few I/O for HyperRAM. We have some for an SPI bus, the SPI bus there for the pseudo-static RAM, which also goes to the ESP32. So we can do some really nice work between the P2 and the ESP32 over that SPI bus. Now also too, we have the HyperRAM that has its own lines, and notice too that on the left-hand side, if you're curious, that's a place for an extra super cap, or could also be a connector there for a little battery for the real-time clock, and that connects to the real-time clock chip underneath, because there's solder pads under there. We have a little look underneath the board. I think we can do that. Okay, there we go. Okay, where are we? There we are. Flipping the board over. Get back to it again. Here we go. Come on. Flip. This is a flip module, this one. I think everything's slowing it down with the Zoom and my VirtualBox running with PCB programs. I might just turn that part off. Come back to this. All right. Well, we'll leave it at that at the moment, but we can see that underneath we have areas there for connecting up to the P2D2, a large heatsink area for the P2. And so it's an extra couple of layers for heat sinking if we're really pushing the P2, which we could be with this extra module on board with a hyper-RAM and other functions and so on board. So we can connect up that way. It's not responding very well, I'm telling you. Anyway, so we have that an extra, and you see right in the center of the board. I might even have to get this to reload those files just so I can reset this. So I'll get it to load the files again. It's very slow at the moment.
So it seems like the P2 PAL would benefit by having these ESP32 drivers we were talking about earlier significantly.
Yeah. Well, that's right. We have the different drivers, but remember that we can load up the ESP32 as much like we do with the USB serial. So we can talk to it serially over Wi-Fi, telnet connections, and just communicate with the P2 that way. And of course, we have all web server functions, a lot of extra functions, and the Bluetooth functions built into the ESP32. So it's a very nice add-on. And it's not like it's an extra module. This is a thing. It's not like we have to come along, here's a P2 eval board, and then we plug in the ESP32 module. No, we just have the P2D2, and it's very compact. And so you can imagine that when that plugs into your board can be a lot simpler, because all the smarts and the power supply and all those things that are common to the P2 are all built into the one module. And so that makes the job a lot easier of designing new products. You can just concentrate on getting that product out, testing it. And if it comes time to do some real production, well, you can always just integrate the P2 chip itself straight into your board once everything's working. But if you're doing low volume runs, the module's the easy way to do it. And prototyping, it's very easy, as you can see, because I don't even have to build up do a PCB. I can just make up a bit of matrix board like that we saw up there. Now I'm still sharing this, so it's probably not much point at the moment. I'll turn that off. So we have the matrix board that we can just make up, and so we can test out a concept. We want these connectors on here, whatever connectors we have. Plug in the P2, P2D2, and away we go. It's all running. And of course, even without any software loaded, I can talk to Tacos and ROM and start exercising that hardware, and it all works. So this particular board, by the way, was originally done up. I've made lots of little boards for the P2 and FPGA ones as well. That's VGA up there through a little VGA adapter. I also have room on here for, here's my little WizNet module that I have. You've probably seen these ones before. Okay. And that one's still got all the pins sticking out for probing, but it's designed to plug in straight in upside down into the board, nice and flush, so it doesn't sit off the board. And all the pins are bent from misuse. This is what happens on the bench, of course, we know this. And I tell everyone to handle with care, and then we throw it around ourselves. So there we go. So this is plugged into the matrix board. As you can see, it's very flush, especially if I chop those pins off. I don't need them in normal use. so we can have Ethernet port on our board very easily. In fact, the P2 lab board, the development motherboard, has all those connectors, your HDMI, VGA, USB, Ethernet modules, etc. Everything that you would normally need, and an area extra connectors for plugging in your prototyping board, matrix board, or whatever you want to do with that as well. And also has room. I probably don't have enough time to talk about that lab today, and I'm still finalizing it, but it's basically everything that you need to pop it into a box. And what sort of box can you pop it into? I've got it over here. So you imagine the P2, can you see that?
Yep.
Does that look like a PCB? No, it's a backing plate, isn't it? A drilled backing plate, but that's the right size. Here's a P2D2. Imagine a board that takes two P2D2s, up to 2 of them. We can use one as a PC function, and another one as a target module, loaded with connectors all around. You can use that standalone on the bench as a PCB, but now you want to build it into a product. What we do to do that, we take a standard box, enclosure that's readily available. This one has a clear lid. We turn it upside down. We use a clear lid or whatever lid we have. The PCB is the same size as the lid, sits there. And if I tip out all these components here, we cut out notches for the connector in the rim of the box, so we don't have to do any special cutouts inside the box. Drop that straight down over the board, and when it screws together, then it's nice. And we can put that in little keyhole mounts on the back here, put it up on the wall like that, and on the front of it, well, one of Ken's 7-inch HDMI touch screen displays maybe might be good, or perhaps another little touch screen, keypad, and so on. So we have all those options there for it.
Well, you know, for people who have or haven't designed products, you're potentially saving them a ton of money and time. You know, we engineers, many of you here, underestimate what it takes to get stuff done, but you've worked on this for a year. You're on your 4th iteration of P2D2.
Yep.
Everyone else would go through the same iteration, and you could save us all that money. We shouldn't obsess over having exactly what we want in the right color we want and everything else. And you have JMG nearby, who's made probably 1 million component decisions for you.
Yeah. So James is very, very good. I don't know. He really scours the internet and finds all these components. I think I can't remember where the switching regulator came from. JMG probably mentioned it as well. And the Scilabs chips I've used before, and that's that's a bit of an elbow thing where I've been but I like the Scilabs chips, and even though it's been a bit of extra work, it's worked out really well. I'm really happy with that now. And so yes, when we design a board, sometimes we try to design it for volume production, and we use that little cheap micro when we spend hundreds of extra man hours trying to get it to work. And then we've got the P2, and then we have hardware problems and so on. We can simplify that. We just want to test out the concept. We want to be able to demonstrate that. We're going to need money. We're going to need customers. They're going to be happy with us. Will it work? All these different things. And so we can take that P2D2 board, either make it up on our own little bit of prototyping board, or take a unit that has the extra prototyping area, plug-in area, so we can put in screw terminals and so on, and anything else that we might need, and a touch screen interface, anything onto it. Put in your own enclosure. It doesn't really matter, but it's designed to fit into a box, and that way it's nice and easy. So the P2D2 with the P2 PAL and the P2 Lab, or the dev board, just means that we can have everything on the bench running. And if we want to dedicate the P2 to PC functions, because this is great, this is the whole development system, it's all totally standalone, then we have another P2D2 in there, as well as a target processor that we can talk to and program and test out in here. So
the P2 PAL is like P2D2 is between R2D2 and C3PO, right? They're a pair, and will be together in many cases.
Yeah. So now you're talking about so the P2D2 originally started out as a reference design, breakout board and reference design. But with all these extra devices, and I have other little tiny modules coming along too that are very useful for prototyping with. So not competing at all with any of this other. By the way, the microbus is also available on that P2 lab, so we can plug in microbus modules directly in there as well. So that'll be very useful, and just means that you have a concept, you want to try it out, you can try it out. You don't have to go through the hundreds of hours of pain before you get anything that doesn't work. You know what I mean, don't you?
Oh yeah.
And this is what happens. Yeah. So you know, you want to get that idea out there, and later on, well, you can refine the design. You know what you need, what you don't need, and you can design that into one step product.
So Peter, we have one viewer here, Dave Matthews. He wants 10 P2D2s. And I think you're another month out, you're making another prototype, and we know this takes a while, these iterations. So do you think in the fall that you'll be sending some boxes over this way and to TMOS and wherever else they need to go? What's your best guess?
Yeah, because when I get these boards, look, all the boards have been done except for the final P2 lab board. That's really just finalizing the connectors I want to use. It's mainly a big connector board and a few other things. But once they're done, that artwork should be off next week. When I get the boards back, make sure they all work. I'll probably have to make up a few there, and I'll get some help doing that. But really, it needs to be pick and place assembly. But that's in low volume, you can't really do that, and especially when you're not sure of the design yet. Right. You need to make them up.
So you'll hand assemble with your in-home reflow oven, your toaster oven, and then you'll go to the pick and place line when you know it's all right.
Well, that's only just for the first few prototypes, and I have other facilities I can use for pick and place and better reflow and so on. I think even Ray's offered to help as well, Occluso 99, and but there's other people around here I can use, and they have very good facilities, but I can't really commit to that until I know it's all working, and then I don't need to make any changes. I can just make them, and they'll be nice, and then that's great. Box them up, ship them out.
Well, my impression is the forum members are supportive and are patiently waiting, and they're going to stick around while you get it right. About what will you charge for a P2D2?
You know, I had that the basic P2D2 one. I think I was charging about $75 US for it, and that's just basically to cover costs. Although it doesn't, of course, as you know, because there's a lot of costs and revisions and everything else.
Oh yeah.
But the thing is that I just want to, well, look, I don't have any problem. I can just make this for myself much cheaper in the long run. I can make it exactly the way I want and everything, but we like sharing. You know, this is what happens on the forum here. We love sharing everything, love to share that. And realistically, once it's in any kind of even low volume pick and place production, my cost would come down. I have to get quotes for that. The P2 power board on board there with an ESP32 will be a little bit extra, of course, but the ESP32 module is quite cheap as a component. That's what I love about it. It's like, why would you bother with a chip when you can have that little module and have that the P2 power? So for development, I can see that being used a lot, but you don't have to have everything on there. You can just have the P2D2 as it is. You can use that standalone, and that works right now because we can just plug that into USB, and even in that little header there that you saw before, I'll get one of them up now. In here, we can plug in little resistors and everything else. So if I want to plug in an LED or a resistor, come along and just push it straight in. So here's your plug-in breadboard straight away.
Good.
Okay. So that's great. So little wires and everything else we can just hook around, and we can flash LEDs, do whatever we want with that. And that's a great, you know, look, you fit 10 of them in your pocket. And in fact, compared to the P2 eval board, which I have misplaced now, 4 of those will fit onto a P2 eval board, no problem. So P2 eval is is not really good for building into products, as you know, but P2D2 is great for prototyping and great for building into products as well.
And also, you've got a friend, at least for the American customers, Jim Kenny's agreed to ship them out, and this is a good low-cost way to get them to the customer. You know, much cheaper than having us stand in the way and just adding the expense. So this will be very helpful when the time comes.
Yeah, no, it's been really good there, and because we have a community spirit with the forum, and it's really good because we're just trying to help one another out with this, and you're like, I feel really stressed and bad because everything's been delayed and delayed and delayed with this, and I have all these P2D2s here, you know, like, you know, you want those, there's other ones scattered around here, but they're not good enough. And so when it's good enough, and this next one should be perfect because I've gone through the footprints and everything else and any little detail, I've tested that out and modified my own boards here, and I know that they will work. So I have very high confidence that it will be working fine. And then that's what you get. You'll be able to get that and have a development system in your pocket. And in fact, you can plug that into your phone.
Well,
you know,
I recognize that you've got well over 1,000 or more hours in this, and so many iterations, probably $10,000 of iterations invested in this. It's worth whatever you want to charge. We'll be happy buying them. I'm sure the whole community will do that.
Yeah, I'm sure. But at the same time, there are some that can't really afford that. So I'm not trying to make money out of this. I'm just trying to cover some of the costs, you know, and so I appreciate the patience that the forum members have shown, because I don't like manufacturing the stuff. I don't like having to get them assembled, and I normally have other people do that, but I do like to prototype them and test out the first units. And you know, when you make a unit up, like the very first P2D2, you go, okay, well, I need to move this connector around, I need to do this, need to change that. So you see a lot of things you can improve in manufacturing and design. So you have that close, intimate contact with the design part of it. But once it's working fine, out it goes, and production can just, well, I have products that I've done that with over the years, and they're still, you know, almost 2 decades later, they're still being produced. So it's a bit like the basic stamp, I suppose, or the propeller chip. You know, it's products. The products are still out there, and and that's what I like to get when I design a product. I like to design a product, have it just right, and then someone else looks after the manufacturing and shipping of it. And so, yes, I'm not set up. Sorry.
I'm ready to distribute whenever you're ready. I'm there for you.
I've got a big box I want to pack up. And so I've got a lot of other extra stuff. I've also got other stuff I need to send over to Europe and to the guys locally. And I have some of these other P2D2 boards I have now. I'm going to reprogram the firmware so it works, it's updated and all works with these standard ones. And they're just being shipped out as little freebies to various ones to help them out. So, yeah. So anyone and everyone can have a P2 in their hand, literally, and just plug it into the PC, even into the phone. As I said, you know, I have a serial port on the phone, so you know, through the USB. So you plug that in USB straight into the phone, into the P2D2, power it, and start talking to it in Tacos. So we don't need a programming environment as such. We only need the serial terminal. That works really well. Over the Wi-Fi and Bluetooth, it'd be even better, especially with the keyboards and mice. Questions, maybe.
Yeah, questions from the chat or whoever wants to ask.
Yep.
I have a question.
Yep. Yes, Chip. Thank you.
So do you have I don't know if I missed it, but do you have the capacity to build these things?
Myself, no. I have workshop full of parts and equipment and everything else, and I can test them out, but I don't really do any real production myself. I really only just do, you know, the small few prototypes and so on. Now I have various people around that do pick and place, that have you know, so I know them, and you know, but of course China's always offering to do it, but I like to keep it local. So as long as it's reasonable, and I can keep tabs on the manufacturing process as well if it's done locally. Yeah.
Yeah, because that might be a really viable kind of industrial product, but you can't. I know you couldn't solder all those things by hand. It's too much. It'd be like $75 of labor.
Well, as you know, it's not hard because you have the stencil, solder paste that, but the pick and place, manual pick and place, I have it set up nicely, and I can, if I do 4 of them at a time, which I can do on this little mini panel, I can do 4 at a time, and then pop that into the oven. Out it comes. I did a batch. I had terrible solder paste, so I got some new solder paste, etc. But I'm really waiting to do the new boards to do it with, and I'll just check them out. But I only do enough myself just to make sure that it's fine.
Yeah, yeah. Do you know how many components are on the board, and is it double-sided or single? It's double, right?
You can have an optional. A few optional components on the reverse side, but really, as you can see, the board does not have anything on the reverse side.
Okay, good.
And so it's all designed to be on the one side. The reason for that, and I might have shown you before, was that remember that this board is done in such a way that it has the 0.1-inch headers on there, okay, and then it also has these 0.05 headers or 50mm headers all along here. Now, you can put pin headers in there if you want, but in this case, we can chop that off, turn that into a surface mount module. So you can imagine, we can surface mount that. Yes, exactly. So we can come along now, and we have a PCB design, but we want to avoid all that, so we solder that to our PCB. So that's another option there for production as well. You don't have to worry about the P2 part of it. You can just put that module in. And if we can make that in volume, that'll be really good because that'll just bring the prices down and everything. Yeah. Really nice. Yeah.
How many parts do you have to surface mount? Is there like 30 or 40?
I haven't done the exact count at the moment, but the thing is that with the I'll just have a quick look at what's on.
I don't think it's a difficult pick and place from what I'm seeing, and that header could be done with our selective solder.
Yeah, and so with that those components, I've adjusted the footprints for them too, and moved things further apart and so on. The little problems I found in manufacturing just improved the design of it in such a way so it makes it easier to assemble now. And I had problems with the little switch mode regulator and also with that little USB serial chip. And now I've redone the footprints for them, so there shouldn't be any problems with assembly in small volume. And pick and place, of course, won't be any problem because it's reflow oven and everything else profile. It should be fine. Yeah. So now, Ray, I just see a comment there. I saw a comment there from Ray. Would you like to?
Preserve flexibility for the user and leave the header off.
Yeah. Okay. Good. Yeah. So there's a component count. You mentioned before about there's capacitors, the resonance. I use resonance as much as possible because you really want resistors smaller than 0603, but I don't want to handle them. So resonance are a good way of doing that. You can have a small component and all those resistors in there, and then really it's just the P2 chip. And as you can see, just on the board here, get one of the boards up. So really, main components, putting aside the sockets, P2 chip, the clock generator chip, the switch mode regulator chip that's on there. That one's missing one there. That's probably what's wrong with that one. And of course the flash chip that we have on there. They're the main components, and the rest are just passives. So we do have a couple of those little USB protection switches or current limit switches that are in there, so we can turn the power off on the SD card. So it doesn't matter what state it's in, we can reset it with confidence. Once it's a product in the field, you can't just come along and turn the power off on it and so remotely. So that ensures that software can reset the SD card as we need to. So there's component-wise, there's very few on it really, but it's just that they're packed in together, as you can see on some of the diagrams there.
Carol asked about the dimensions as
yeah.
well.
Yeah. So dimension wise, in fact, what I should do, talk about dimensions, and I did something on the P2 eval board. There we go, the P2 eval board. So here we go. Here's a P2 eval. Best way to find out about dimensions is to get the P2 eval, lay out all the boards, and there's a P2D2 with the extra headers on it. If I take the headers off it, so it's just, oh, sorry, there it is, just SMD, we can see, look at the size of it. In fact, even with the headers, we have 4 of them that will fit on there with room in between. So it's very small. You want to know the exact size of it. I can tell you, I just had the ruler here.
Tubular gave us some dimensions. Imperial 2.15 by 1.1 inch.
Yeah, that's it. With the 0.1 headers on it, it's 2 by 1.5. And if I use low profile headers on there, then the actual height of it, because there's no components on the other side, it's 1/4 inch. So, you know, it's a very compact module, and if it's surface mounted, it's even more compact again. But it's totally up to you. It's very flexible in that regard. When I ship these P2D2 modules, I have the standard size headers. What I'm going to do is not solder those on, because some have requested various options. But this is the form factor I prefer, to have it soldered on to that component side, so it flips over and becomes a component on the board. And that's why I do that there. Now, any other questions? Just unmute yourself. Saw a few on the chat there.
I had a question.
Yes, I do.
Yeah, some of us bought the original board for $75, and now you come up with the extra boards. So the question is, how do we pay you, get the other extra boards and make sure we get them all at the same time?
Yeah, well, with the P2 power board, if you depends, would you need hyper RAM on that P2 power? Because if the ESP is enough, and the SD micro SD socket, I can ship them no extra charge. It's like it's like that little extra that I can include with it for the delays. Is that sufficient, Dave? Or
well, I think most of us, or I think a lot of us would get the RAM too. We'd pay you extra. Money's not the problem.
I think he's thinking also about the process. So when they're available, and how do we go about buying? Because people want to click somewhere and buy it. And so, yeah, if Jim takes care of that, that's good. And if he doesn't, we can jump in and help this out and get these to people. We're happy to do that too.
Oh, that's great. I think originally I don't really want to manufacture these. It's something someone else looked after the manufacturing of it and just distribution of it. That's great. But initially, I need that close contact with it, and it also creates that bit of stress and tension, I suppose, because here you are, people want them, but it's not quite right yet. You can ship revision 2, revision 3, and they say that was great, but I need to buy revision 5 now. I just want to ship revision 5 to you, just like we have the P2 is gone through many variations. Now we have the P2 chip, and we do actually have a Rev C though, mind you. That's fine. That's all good. So, yes, Dave.
I was just going to say, when you finalize your design,
unit 1. Yeah. Well, what is it? Yeah. Just bring it up, put it in the floor there. It's fine. Thanks.
Sorry, I just had somebody had their mic unmuted there, Dave.
I've got him muted, so he can ask again.
Yes.
Yeah. No, I was saying if you don't want to make them and Parallax doesn't really want to make them, maybe Micro E would take them on as a product.
Yeah. With whoever manufactures them, I suppose it's well, Ken, I don't know if I've asked you before, but yes, if Parallax was, but somebody, as I said, I'm not really, what I like to do slope chip. You know, he likes to have his head down in the design of it. He's not there at Parallax in the manufacturing facility, worrying about the manufacturing of it. And so this is what I like to do, but I will, you know, manufacture enough just to make sure that I'm happy with the design.
Well, and I agree. I think we want to make all those engineering dreams come true, as long as we can do it in a viable way and be productive at it as well. And I'm not opposed to it if people really get behind this and this is their solution. Yeah, we have to make them available for our own existence as well. For the same similar reasons.
So I'm sure that once we have these PCBs and they're sampling out there, and then I can do some larger shipments out because I'll have enough components in anyway, so I can go straight to that. The trouble is that I have components that I use for manual placement. Once I do pick and place, I can't use those particular ones there. So I'll just have to make sure that it's right, and I'll have to do the hard yards just to get those initial shipments out. But I want to get them out as soon as possible. So for you guys, well, you know, this is like going to be, I'm hoping later in August you will have all these, because once I know it's working, and it's not like it's brand new, this is a revision, then I can just get them made up and shipped.
Yeah, and spend your time like you're doing. I want to reinforce, I think your energy is in the right place. Get the design 100% right, and that bill of materials entirely settled, and the layout just right, and it'll find its way perfectly. And meanwhile, sell us a few on the way, and people keep buying them. But focus on that, not perfection, but completion.
Yes, perfection. We never achieve perfection, that's for sure. And but it's got to be reliable. And this is the thing: is if I ship it and I felt, well, this wasn't quite right, and it's going to be a reliability issue, then, you know, if it's a feature thing that somebody might like, that doesn't it's not as important as the reliability. So it has to be 100%.
So yeah, Peter, once you get to that point, we'd be happy to build them. You know, once we know this thing is fully settled and people like what they see, that's a good time for us. Until then, we could spend money and time like you are. So you keep going, and we'll know when that time is right. But Chip?
Yeah, we plan to make some kind of really simple, low-cost entry module that doesn't have, you know, a fourth of what yours has on it. But the margin on these things is like almost nil. But in your case, what do you think your BOM is at like 100 pieces?
Okay, I haven't done any final costings on it. I think the major components are there, as you can see, with the switching regulator. The original design was much cheaper. It just had linear regulators on there. And if you actually had to have a module that was cheaper, that'll be something more like the original module with, it doesn't even really need USB on it, but in this case, it's quite cheap to add now. And the original module, if we remember, just had the one little switch mode regulator. We probably have enough room to put in a discrete switch mode, cut the BOM cost down, and use linear regs for the I/O. Because, you know, you're talking about low cost breakout type module, and you don't have to load up all the components on this. You don't even have to load up the SD part, etc. But once you've done the BOM, and I'll get back to you with those figures too. I'll do that myself. And the major component, of course, is the P2, and the next one down is the switch mode regulator chip. That's about $3.
Well, one thing we can certainly do is we'll give you the P2s at our cost.
Oh, that's great.
Yeah, count on that. Right, Chip?
Yeah, that'll be really good. Thank you. Yeah.
Yeah, that'll be far less. Well, not far less, but a lot less than what you're paying.
Yeah, well, you know, you guys have been really good, because, you know, you've just given me all these chip samples and everything and so on. I've still got some of the, you know, originals here as well. And who's going to use those now? But they're great. They'll be, you know, I'll sell them as collector's pieces on eBay. You know, you want the whole box set? Well, here you go. Highest better. But yes, so the P2 chips, P2 chip is the main component. The rest, as we know, is really nothing. That USB chip.
On the question for you too, on the P2 PAL, the C3PO friend of R2D2, P2D2, when we publish our vision for the ESP32 firmware, can you please tell us if it's going to meet your needs? Because I think you mentioned there's some firmware there. People are already using it as default mode. And what we would do, I'd like to know that it fits your need or not, if it's not even needed.
Well, yeah, you know, like the ESP32, I haven't had any experience with, and there's so many different modes available. I've been taking them into account. That's what has delayed the artwork as well, because I want to make sure that when it goes on there, that I don't need to do a revision of the board. I have enough I/O, it doesn't conflict, but I have the functionality and the flexibility that I need in that design. And so, yes, we can use a serial port on there. We can use a secondary serial port. We can use a high-speed SPI bus, a web server, and so on. We can just load up ESP32. There's so many different options. It's like, you know, I don't think I'll get to explore them all, but I'm sure there are many others that will be able to come up with different applications.
Great.
Yeah. So that, you know, yeah. So things don't work properly. And next time I do this, I might have real boards and have set up a bit better again. But yeah, practice sessions. Sometimes I think I practice this Zoom stuff, and as you mentioned before, we always find new problems with Zoom. But once we can do it that way with the new boards, I'll be able to demonstrate those as well. Show you live working models. I'll put that up on the forum. And as I said, the P2 Lab. This is a good thing because you have a product. You need to finish it, and you can put it into a box. You can have the connectors and the prototyping area that you want on it with the connectors that you need. And so if you need to customize the box, how hard is it to do? I just cut into it with a nibbler or anything and then pop that over the top of it. Print up your decal for that. And in fact, I use the polyester paper, that laser paper, label paper. That's you can't tear, and it comes up beautiful as a label. So
you look for product development. You just saved a customer a year of development. Even our simpler boards take 6 months, really, to get past the first couple iterations so they're good enough to sell. Yeah.
Well, as you know, in all the movies, you have the one guy come up with something overnight that's a full finished product, like a smartphone. We know you can't get that finish on a product. And if you want to even show somebody you have a potential customer, they need to see it. You need to see it too. And get the feel of it. You can do that with an enclosure, having designed to fit into an enclosure, and at the same time being very flexible for development purposes. You know, it's really good like that.
So it's fair to say then that P2 PAL and P2D2 are ordered as well as your breakout board, and that when you get these back, you'll see they work, and then we can do another show and tell.
Yes. So probably September, I'd say.
That's fine.
Go through the door, yeah, and you know we'll have a look at the calendar and I'll fit it in there, and next time Zoom will be better again, and it'll be sorted out. So that'll be good. Yeah. So any other questions?
Well, following the chat, people are very enthused and looking forward to the next step, and very appreciative of all the work you're doing. And
so
you're so close.
Yeah, so close. And but it's been a while. It's dragged out. You know, early in the year, COVID and everything else, and you know, I think I was a bit run down. I couldn't get into it properly. But then we got the USBs going and sorted out, and that took quite a while, backwards and forwards. But now it's easy to make changes, and the USB serial part of it is down pat. And as I said, we have so many options in it. I couldn't even, you know, take a whole Zoom session just talking about that USB serial chip. And so, but as I said, it's so cheap. So why would you use an FT chip in there just for serial? It's just, this one's much smaller and faster and far more flexible. So yes, that will be available as a little module as well. So you imagine that part of it there with the socket and that as a little SIP module. So you can put it in vertically into your proto board, your matrix board, and it will also have RTC on there as well, because the that UB3 chip that we're using has we're going to use the I2C bus. So let's
one
use
last
that
question
effectively.
too. What PC board design program did you use? People will be curious.
I've got Protel 99 SE, so you know, the new Altium came from that. So I'm stuck with that because it does everything I want it to do. I have all the libraries for it. I keep trying to use KiCad and DipTrace.
No, most importantly, you know it. That's all we got to know. You use what you know.
Yeah, and so that works well for me. And what I like to be able to do is just on the big monitor, 4K monitor, just be able to see the PCB, and you know, like I might even just select all the copper for the ground plane, etc. I don't have chips layout, mind you, with the big TVs, but on the big screen I can see where the copper goes, and on 2 layers I can make it work. You know, low noise and everything on there, and so yeah, I just make sure of that. And that's why I'm always trimming it up that extra little bit. You can't get that with any auto routing type program, definitely not at all, especially the way I've got it packed in there, as you know. So, but it's nice. I've got everything I want, all the options that I want on one side of the board now, and that's worked out well because that real-time clock chip, you can't even see it. It's up in the corner, and so is its backup capacitor. Yes, well, you probably can see it, but just up in there, top corner there. That's a real-time clock chip. It's two tiny little squares there. One's the capacitor, one's the chip, and it looks like a ResNet. In fact, they're real-time clock chip, but it has Unix time on there as well. It has timestamps. You can have I have resistors coupled to the header pins, so they don't interfere with the header pins. But what they can do is on those port pins, you can have external events when the unit's powered down, and it's going to capture that. So when it powers up, it looks and goes, I had an event, and there's a timestamp for it. So you can even wake up the P2, I guess, but bring it out of sleep.
Well, Team Oz, the future home of Parallax's, what would you call it? The down under location?
Yeah. Well, we've got to catch up with those guys down Melbourne, but you know, they have all the lockdowns there, and they have big scares up here, you know, because you know we're up north of Sydney, just as far as Sydney is from Melbourne, and so what happens is, you know, like we had a couple of girls come up from Melbourne and snuck through the border and everything else, and they tested positive, so we've had a bit of a scare there locally. But here it's pretty good here in Queensland, where we are in Brisbane, and I know I feel sorry for the guys down there in Melbourne because, you know, but they, you know, as I noticed 2:30 in the morning, there's one of the guys there still on the forum, still working away, so it gives us time to get things done.
Yeah, right. Excellent. Well, thanks again, Peter. This was a wonderful presentation. Everybody enjoyed it.
All right. Thank you, everyone. And sorry, you know, it was a bit of a last minute thing, but I thought, well, you know, let's not miss an opportunity. Yeah, so it's really good. So,
yeah, and if anybody else wants to jump in, we have C programming with Eric Smith next week, and then we have 3 weeks where nothing is scheduled, and those are open. So, anybody has anything to share, just let me know.
Thanks, Peter.
You're very welcome.
Thank you.
Have a wonderful morning, evening, night.
Thank you, Ken.